Zombie Apocalypse.
Today's topic is singly reinforced concrete beam principles. So this time, let us try to counter-check yung mga principles behind the investigation and analysis of beam. So we will focus first in singly reinforced, and then followed by problems to be solved, then followed by doubly reinforced. So I will separate those two concepts so that it would be easy for us to understand the necessity of doing singly reinforcement and doing doubly. So let's get ready to be neurorized. Okay, so the very reason of doing the analysis of a singly reinforced concrete beam under tension reinforcement only muna. So meaning, the base default analysis of designing a concrete beam under flexure is of course is to reinforce it by its very own weakness, that is under tension. Already proven by under cracking condition, and most likely it will be cracked due to the fact that factors like yung width of the beam, the cross-sectional area of the beam, the span length of the beam, some vertical clearances required by the space involved, and etc. So those are the prequalification why the beam always suffers from cracking conditions. So therefore, there is a large probability that a concrete beam should be reinforced initially by tension. Now, what are the conditions regarding that? Then I will try to discuss as we progress. Okay, suppose that we have a tension reinforced system only, so designated by this, let's say this is A sub S, okay, still area, and same nomenclature, okay, but notice that we are introducing D. I already discussed before in uncrack and crack stage that D is what we call the effective depth D, okay. So, as our NECP 2015 describes and defines, nandun po yan, no, sa may notations and terminologies. D is what we call the distance of the compression fiber to centroidal condition of the longitudinal tension reinforcement, meaning we need to understand that we need to find the centroid of the rebar group. Let's say, for a single layer, meaning one layer yung pinagtatama nung diameter. So therefore, sa gitna lang yan. So therefore, it's automatic that there is half condition, okay, dB over 2, and another dB over 2. So ano ba yung dB na yan? Yung dB is what we call the bar diameter, okay? Now, what if multiple layers? Of course, as mentioned, the centroid group, so let's say we have, for example, 5. So we cannot simply say that, let's say, with the gap distance of minimum of 25, that I will try to discuss sooner or later, the minimum gap is 25 mm. And the centroid should be identified completely. Let's say this is the dot. And of course, techniques of Barigno's theorem may now takes place, assuming, let's say, this is bar y. So there's a need to compute first what is the value of bar y. So to identify that, you may use the Barigno's condition that total area, okay, is equal to componential areas, okay. So you can do the trick, and if you want to make it Barigno's, no, under centroidal, don't forget that if you multiply bar y, then should be the bar y individuals, okay? So that it would be meaningful for us to find the bar y, and that defines D. And while C is a definition of the distance from the compression fiber to the neutral axis. So yung C, dinidefine, let's say, ito yung compression, ito yung, let me use another color for this so that it would be easy to view, okay? Let's say you have this neutral axis as projected here, tension below, compression above, assuming the beam is suffering from positive moment. So therefore, C is defined as the extreme fiber compression element up to the neutral axis. Okay, that's why this is C. Okay, and the D is the distance of the rebar group, tension rebar group up to the extreme compression fiber of concrete. Kaya ito yung tinawag na D. Now, notice that if you recall that we have two stages of cracking, no? There's linear and non-linear, linear crack and linear uncrack. So, but what is really happening on the beam when we try to subject that into an actual stress distribution, it is found out already by so many times due to testing, okay, laboratorical tests. So this is the stress block that we need to understand. So it is somewhat like a combination of parabolic, linear, and somewhat like elliptical on some portions. So the area seems to be non-uniform to how do we calculate the prescribed area. Of course, we understand before that the forces as discussed by strength of materials, it should be taken as the volume of the area cross-sectional block. Okay? So again, the same nomenclature. So we have compression force C sub C. Okay? Assuming wala muna tayong compression bar sa compression side ng concrete because that is another topic to discuss with. And nagkaroon dito ng konting tension of the concrete kasi may konting lagpas, no? And the tension of the steel, no? Ito yung kunaring equivalent stress block, okay? Of course, don't forget that there's always a strain distribution. The strain of concrete under maximum condition and the strain of steel under the condition where the steel exists, okay? So this is the volume block that we need to understand, okay? So there are two ways for you to compute that. First way is to analyze it by 3D model where you need to get the volume equation, but it's very hard for us to understand the equation. Next would be the strip model. What is very problematic here, it is non-linear, no? Notice that in the my over the I, no? Ganyan muna sana. So this is the definition of the my over I. Question would be, is this applicable to this area? The answer is no. Why? It does not execute direct linearity because this is already a nonlinear analogy. So therefore this equation would not exist. So therefore strip modeling may be hard to analyze because it will be a strip of series of integrable equation that is taken into a partial differentiation. So that would be a topic of higher condition where plates and shells may be applicable, or what we call the finite element condition where we are delimited to discuss. No? So therefore, there should be another way to compute this very hard volume. That's why there are so many empirical equations exist for this. No? May ginawang triangular, may ginawang hexagonal to confirm that it should capture the same idea. Parang it is formless, but in the fixture of a particular area, it should be of the same value. Kaya nagkaroon po tayo ngayon ng tinatawag na simplifications of lecture theory for design. So the main issue is to simplify the very difficult, no? I mean the most hard to conceptualize on how do we compute the compression block volume. So therefore, the engineers, okay, I think it is being designed. This is being designed by ACI committee, no, specifically 318. So they try to understand, no, how do we simplify this further into an answer where we are going to get if we are going to do the same, if we are going to deal with the true stress block. Okay, what is the number of assumption that they have did is the tensile strength of concrete is neglected in flexural strength calculation. I already explained why in our past video lecture, no, you may revisit our discussion on the uncrack and crack condition. So the tensile strength, kasi because we understand that under ultimate stress design, yun po yung focus natin under NECP 2015, it is said to be that when we understand the concept of USD or ultimate stress design, the crack is a main factor. So therefore, the tension under the concrete condition, okay? I mean the tension side, no, of the compression of the concrete, no, is said to be negligible. It is due to the fact that there is already a tension still residing on that region that considers the loss of strength of the concrete under tension. There is an equivalent code in our NCP 2015. So side by side, nagdi-discuss natin para mas maunawaan po ninyo saan nanggagaling yung mga codes natin and calculation basis, it's on 422.2.2.2, so same attribute of the statement, okay? Actually, ito yung talagang original, galing yan sa ACI 318. And we just only adapted their code, so we are using ACI 318. So there are so many versions already. So therefore, in general, so we are going to deal with this, no? So I think it's CI 318 with a metric unit with M. So usually nilalagyan na M dito to denote that it is under metric. So I think it's dash 16, no? So dash 16 siguro, or dash 15. Okay. So that's the number 1. Okay, number 2 assumption. The section is assumed to have reached its nominal flexural strength when the strain in extreme concrete compression fiber reaches the maximum usable strain of E sub CU. Ano ba yung ultimate? So under 422.2.2, subsection of 422.2.2.1, the maximum strain of extreme concrete compression fiber shall be assumed equal to 0.003. So meaning we need to get that E sub CU, okay, will not be more than, okay, or you can say that it is assumed to be equivalent to 0.003 for us to have a better idea on how do we deal with the stress. So where did that value comes from? Proven by test already under ultimate stress condition. Okay, this is one of the most controversial part. Number 3, the compressive stress-strain relationship for concrete may be based on measured stress-strain curves or may be assumed to be rectangular, trapezoidal, parabolic, or any other shape that results in prediction of flexural strength in substantial agreement with the results of compressive test. No? Actually, this is already taken in our code 422.2.2.3, same paragraph. So usually, marami kang modeling, no? Kasi yung stress block na sinasabi na pag ganon, equivalent daw sila sa parabolic, talagang pure parabolic, parang ganito, okay? Pwede rin daw siya pwedeng ganito, let's say trapezoidal and so on. Okay? However, there is a one very good assumption to use. That is the Whitney stress block, no? Si Whitney, no, idealizes that the concrete beam suffers straight, no, linear performance, but that is already an equivalent stage. So let me draw a little figure out of that. Ang ginawa kasi ni stress block under Whitney is ganito. Okay? Now, let's say this is the neutral axis. Okay? Ito yung nawawalang concrete strength. Is ganito po. Nilagyan niya ng ganito. Yan. Ang konsepto niya is, meron kayong mawawalang area dito. Kunwari, yan, mawawalang area, okay, at madadagdag na area. So, equal din daw yan kapag ginawa ng ganito. Yan. So, yun nga lang, merong gap dito kung napapansin ninyo. At least ito medyo dumali siya. Yan ang konsepto ni Whitney, stress block. Okay? Pero ano yung mga assumption muna na dapat natin maunawaan before we continue the use of Whitney? Kasi the entire NSCP 2015 already appreciated the concept of Whitney. So pag inalis mo yung pag-rectangular stress block ng analogy mo, then most of the formulas will now be deactivated. And then you will now use the true empirical, the true equation residing on that, or maybe you can generate your own, but it would be different set of equation. Now, for us to understand Whitney stress block, here are the following points to consider. Number 1, a uniform compression stress of 0.85 FC prime shall be assumed distributed over an equivalent compression zone bounded by the edges by the cross-section and the straight line located parallel to the neutral axis at a distance of A that is equal to beta 1C from the concrete fiber with the maximum compressive strain. Na-explain ko nito kanina lang, ano? Saan ba makikita sa code yan? Under 422.2.4.1. So, ang sinasabi lang po nito, pag ginawa natin stress block yan, ito na is 0.85 FC prime. Ibig sabihin po, pinapagamit na sa atin yung demand capacity ratio under compression, or also known as decompression ratio, to take effect, no, as of 85% or 0.85 of the compressive strength of concrete. And if you notice, kanina sabi ko may gap, no? So this is the value of the height of the neutral axis, small c. And let's call this small a, as code suggests. So if a, kanina nakita nyo, mas maliit yung a. So therefore a is less than, okay, c. So therefore, to make them equal, we introduce a constant, say, beta 1. Yan yung konsepto ni Whitney. The distance C from the fiber. So this is only definition. Also found on 422.2.4.2. Okay, self-explanatory po yan. I'll try to describe this based on the definition of NCP later. And factor B beta 1 shall be taken as follows. Okay, notice that FC prime is, beta 1 is dependent on the condition of the FC prime. So it can be less than 28. So to make this another statement, if this is less than 28 megapascal, okay, and if this is FC prime, sabi nga, greater, so greater than 56. Okay, so pagka less than 28, use 0.85. Pag more than 56, use 0.65. And in between 28 and 56, then use this formula derived from linearity. So the code says for every 7 megapascal of a change, there should be an increase or a decrease of 0.05 megapascal on each side, or 0.05 as a gradient, no, in difference with the 28 megapascal with respect to or relative to the compressive strength of concrete. But I want you to notice something. Okay, now we can obtain, so there's a magical formula here, no? For you to get this 56, sabi pinaka-least value is 0.65 eh. If you take only beta 1 as 0.65 and let FC prime as an unknown, no? Gawin mo, formulation. You will find out that FC prime is exactly 56 eh. Okay? Kasi ang pinaka-least value ng beta 1 is 0.65. So this is taken from understanding as the condition of 0.65 is of supply. However, our NCP 2015 says that it is for 55 megapascal. What happened here? So, what I'm thinking here is NCP 2015 wants to be more conservative, okay? So, a 1 megapascal deduction may take place so that to understand, because this code 56 megapascal is not really exactly 56 megapascal in true value. It is somewhat like a decimal value when converted from the value taken from the English unit, where we just only convert from English to metric because most of the codes are taken from English unit. So ASEP, no, is thinking that this value may be a value for residual condition where may produce, no, a comparable differences. So what would be my stand here, no, as for us to continue discussion. Now what I want to understand is the 56 megapascal value. So starting from this discussion until we end up this module, we will understand the 56 megapascal, since in the NCP 2010, okay, there is a code provision that this was not mentioned, but the least is 0.65. So therefore, we will get also 56 megapascal. So I will already accept that this beta 1 should have a 56 megapascal condition. So as we progress, I will try to use a 56 megapascal, and don't worry, I still accept this one, 55 megapascal, but for me to better analyze, so my main basis now is the 56 megapascal. So kapag ginawa po natin yung konsepto ni Whitney, so ito po yung mangyayari. Ang E sub CU is 0.003 na, papalitan natin yan. Okay? So straight, pero ito na siya. Yan yung stress block. Na dati is ganito dapat siya, no? Gumanon, tapos gumanon, tapos gumanon. Okay? Wala na yan, no? Ang nangyari is napalitan na siya niyan. So therefore, what we need to understand is this volume block. Ito, yan. Ito, sinishadan ko ng violet, siya na ngayon na magiging main area to analyze, ano? Kasi, ito, pag diniretso natin yung neutral axis, okay, so andito na lang yung analogy point. So what we need to understand is that the whole compression volume, compression concrete, no? Ito lang ang kukunin natin. Yan, shaded in violet. So hindi na natin pakikialaman yung gap difference between the value of height of the compression block and the height of the neutral axis drawn in blue. So ito, mawala muna sa analysis natin. Okay? So, and then notice that this is the internal forces. So we will get some moment computations just like what we have done in the crack and uncrack stage. Ano? It is, I think, clear that we can have those. And what would be the compression block looks like as a volume. But of course, we need to take first what is A based on NECP, the depth of the equivalent rectangular stress block in millimeters, and the beta 1 is called to be the factor relating depth of equivalent rectangular compressive stress block to the depth of the neutral axis. So, ito, medyo kung mapapasin nyo, dumali-dali yung ating co-competing volume. So, ito po yung magiging main interest natin, okay, yung volume block na yan, okay. So, ano lang ito, no? Volume of a parallelepiped or just simply the volume of the rectangular block, okay. So, therefore, what do we need to get here, okay, yung sinishade natin, yan na, yung kukunin natin volume. So, it's easy to understand. So, therefore, the compression force would be the true value of that new equivalent stress block. So, how do we get the volume? Okay, just getting the volume, multiplying A, B, and a 0.85 FC prime, so we will get this. And getting T, since there is AS, okay, and then still stress is present, so ASFS. And then we already proved before in the crack and uncrack that C is always equals to T. But I'll take my chance to take my explanation as the sigma or the sum of all compression to be equivalent to the sum of all tension because there can be compression bars. So I would take the general sense. And then by equating them, this would be one of the most meaningful formula in our understanding reinforced concrete. So therefore, this formula is very powerful from this discussion up to the last discussion since C is always equals T. Okay? But how do we analyze Fs? Kasi dito po, ang ating consideration, yung bakal natin pwedeng gumalaw at pwedeng hindi gumalaw or what we call yielding. Okay? Ganito po yan. Pwede kasi yung concrete muna ang nag-yield. Okay? So, if concrete yield first, okay, concrete, okay, yields first, ibig sabihin po niyan, ang ating Fs, ang definition is less than Fy. Kapag tension, okay, meaning bars, no, tension bars, yields first, okay? Ibig sabihin, yung bakal yung unang gumalaw. So, we can say that Fs, mas mataas kasi, no? Is more than Fy. Or maybe equal. Okay? Ano yung understanding natin dito sa kondisyonis na to? Kapag yung konkreto muna yung gumalaw, there's no way for the steel to move after. Kasi wala na, failed na yung beam natin. Kasi ang bakal natin naka-install lang naman sa loob ng concrete. So therefore, if the concrete fails, kasi ang ruling natin, the one who yields is the one who fails first. So in the general rule, kung sino unang gumalaw, siya unang mag-fail. So therefore, Fs less than Fy kasi hindi mo pa nire-reach yung potential niya to yield eh. While tension bars yields first, so gumalaw na yung bakal bago yung konkreto mo, under compression what we are talking about, no, yung concrete. So therefore, stress mo is now performing. So therefore, the bars is now performing and it should be more than or equal to Fy. Okay? Or the yield strength of the steel. Yan ang sinagsabi natin dyan. So, yan yung konsepto na kailangan natin i-understand. So, ano dito yung safe? So, I would like to say that the first assumption is not okay. Why? Siyempre, pag nalaglag na yung concrete, hindi mo pwede lumutang sa area yung bakal. So, laglag na lahat. So, therefore, that is already a show of unsafety principle. But, if you were to use this one of the main agenda of designing concrete, with reinforcement, it is always taken as the bar should yield first, no, if we try to design. But for investigative, mayroong performance yan, okay? But this is a very good citation, okay? Ito yung number one rule natin for safety purposes. Make sure that the tension bars to yield first, or consider Fs is more than equal to Fy. Okay, so malaman natin kung sino nag-yield, concrete or tension. Let's say for investigation, what will happen? Paano natin sasalpakan yung value ng Fs? Okay? Now, if Fs is more than equal to Fy, so, isabihin, this is tension governs. Okay, tension yields first. Tension yield first. Okay? Ang understanding natin dito ay yung kabakalan natin dito is yung unang gumalaw. So, syempre, hindi naman pwedeng i-analyze sa mas mataas sa lagay yung actual stress kasi papuntang failure. So, ang understanding natin yan, if Fs more than equal to Fy, then assume, and use, is not assume. Use Fs equal to Fy because no stress should be more than yield. Magra-rupture na yan for concrete, no? Kasi wala namang hinging na nangyayari sa under condition na ito. Hindi mo na ina-accept for the meantime. But there's what you call internal hinging within the concrete beam, lalo na pag nag-subject to seismic condition. Oh? So therefore, what if F is more than or less than Fy? So that's the compression. Compression, concrete, yield first. Okay? O yields. Okay? Now, i-understand natin yung stress block. Don't forget that this is 0.003. Okay? There's linearity. Okay? So, mangyari, this would be D minus C. And then we know that in our stress analogy that Fs, okay, or simply general stress equation, okay, we know that F is equal to is modulus multiplied by the strain. So if we talk about steel, then steel stress equals to modulus of the steel and the strain of the steel. Okay, so that we can say that E sub S or strain of steel is F sub S stress of the steel over the modulus of steel, where the modulus of steel is observed to be 200,000 megapascal or 200 gigapascals, the average value. So using this triangulation, so using the relation like this, 0.03, okay, kunin ito, as to C, kasi similar phi value yan, do not use phi, baka kasi malito kayo. So, say theta. So, this is theta. Okay? This is also theta. No? Maliit yung theta ko sa baba. Okay. So, this is theta. Is equal to E sub S, strain of steel, as to D minus C. But, again, as we use this, so it will look like this one. Okay? Siyempre, madi-divide. And then, finally, magkaka 200,000 dito, lilipat dito, 0.003, kaya 600. At lilipat ito sa numerator. Okay? So, that's why it becomes like this one. Okay? So therefore, our stand, if Fs, okay, is less than Fy, meaning talaga hindi nag-yield, ano? So, Fs should be calculated as 600 over C, D minus C. So, by that sense, we can now literally, no, assign that those Fs by the true condition so that to identify usually ano ba talaga yung kinukuha natin dyan, yung height of the compression block. Usually, yan na po ang kailangan nating makuha to understand the location and its nature. Okay? To consider what kind of concrete are we dealing with. Is it concrete yield first or tension yields first? Okay? So, therefore, yung A, usually, ang main objective natin to calculate. Of course, kung titignan natin naman ito, yung compression forces analogy natin, magkikreate siya ng moment, internal moment effect. So, therefore, ang ikot ng force natin, pag ganun, ano, syempre, ang ating concrete is lalaban ng pabaliktad. Okay? Para ma-counteract as a result of equilibrium. So, therefore, there should be a moment. So, if we take a moment on T, so, C times T minus A over 2 lang yan. And then, if you take a moment on C, reverse lang. T times T minus A over 2. O, bakit A over 2 yan? Ito pala, bakit A over 2? Kasi rectangular ito. Rectangular din ito. Okay? So, meaning, kung tinan tayo sa 3D volume, nandito lang yung centroid niya, papunta dito, sa surface na to. Okay? So, equal distribution. So, we can say, it is safe to say, that this is just half. Kasi, rectangular na nga yung compression block, tapos rectangular pa yung area ng compression concrete mo. So, we can say that this is A over 2 lang. Kailan po ito nagiging A over 2? Pag ito pong binilugan ko, ayan, ay hindi rectangular, nagkauka, or whatsoever. So, hindi na siya A over 2. Okay? So, therefore, as we perform this, so, nagawa na natin sa crack and uncrack. So, papalitan nyo na C sub C ngayon na 0.85 FC prime AB as taken by this, and T as ASFS. So, take consider, no, what is Fs? Fs ba as Fy, or 600 over C D minus C? So, malalaman natin yan based on the assumption that we're going to do. I'll try to explain that during our next discussion, no, of problem solving. But before that, i-understand muna natin yung isa pa next topic before that. Okay? And then, don't forget that MU is PMN. Kasi ito yung nominal pa lang. Nominal moment. Ibig sabihin, raw forces pa rin nakukuha. Ang kailangan natin under USD, para mag-take effect yung sasabi natin, greater stress is equal to greater force over the lesser area. So, reduction force ang kailangan. So, we need to take, no, what is this phi? That is the reduction factor. Okay, this is the reduction factor. Ito po yung next topic natin before we solve problems. So, I want to discuss this separately so that it would be meaningful and easy to understand. How do we deal with the reduction factor under beam flexure? So then, getting Mn, just plug the value. So, you will get the ultimate moment capacity. Okay? So, this is what we call the ultimate, okay? Para mali spelling ko. Ultimate. Ito, yan. Moment capacity. Okay? So, after that, usually, yan ang topic, and then we compare it with the maximum moment with the beam, and then we can say if that is safe or unsafe if the capacity is more than the actual, and said to be unsafe if the capacity is less than the actual. So, therefore, there could be a redesigned condition out of that. So, ito po yung sinasabi natin, what if may mga uka-uka? Sample lang po ito, ano? May uka. So, we cannot say that this is, we cannot say that this is A over 2. It cannot be equal kasi may uka na ito, ano? So, therefore, let is designated by Z, and then using Varignon, so ito yung volume block, and then C is just only the volume of the interface. So, we can call this as the area of the effective concrete. Okay, nasa code naman natin yan, or the area of the, okay, sulat ko dito, effective concrete, okay, ituloy ko lang na konti, under compression. Okay? Para medyo may guidance tayo. Para pag nag-discuss tayo ng dalawang solve problems, one for rectangular and one for non-rectangular cross-sectional area, so madadalian na tayo kung paano natin siya computed. So I hope you learned something new today. So again, our tradition, you have been neurorized, and see you in our next video lecture. So next topic is the calculation of the reduction factor phi for under flexure, of course. So see you in our next video lecture.